Okay guys, in this video we are going to learn how to combine like terms, and this is leading into algebra. So we're going to take a look at these examples. So these terms are like and these terms are unlike. Okay, so let's take a look at the difference. So here we have 3x and x. They each have an x for the variable, and then they have coefficients of 3 and 5. Now, we can combine these two with addition or subtraction because they have the same variable. So you can combine x's together because they have the same variable and same exponent. Now, you cannot see the exponent, but there is a little exponent of 1. It's invisible. It's one of those invisible math rules on each of those x's, okay? So those terms are like and can be combined. If we look over here, you have 7x and 7y. We cannot combine those. Those are not like. You cannot combine x's and y's. I'm sure you have seen you can't add apples and oranges. They're two different things. That's true. Same with x's and y's. You cannot combine those. So we would not be able to combine that any further. It was just 7x and 7y. You can always add 4 and 9. You know that. You've done that your whole life. So 4 plus 9 is 13. Or if I had 4 minus 9, I would get a negative 5. So I can combine those because they are just constants. They are just numbers. I can combine those at any point in time. If I come over on this side, I have 3a and 3a squared. Those terms are not like because they do not have the same base, same exponent. Now the base being a is the same. Okay, so that's fine. However, when we look at this exponent, I'm going to erase this so you can see better. We have an exponent of 2 on this one here, and this one has an exponent of 1, the invisible 1, right? I can't combine these because this has an exponent of 2, this has an exponent of 1. That's not the same base, same exponent, so they cannot be combined. Those are not like, okay? If we look over here, we have 2ab squared plus 4ab squared. Now, I have the same base, AB. I have the same base, AB. I have a squared symbol on both B's, so I have same base, same exponent. I could combine that. So I could add that, and I would get 6AB squared. Okay? If I look over here, I have 2CD and 5C. I can't combine those because I would need a D here. Okay, I don't have a D, so I cannot combine those. They are not like. So in order to combine, you must have the same base, same exponent. Okay, and that is for adding and subtracting like terms. Okay, so we're going to do a couple of examples of how to do this now. Okay, there are some steps that you will see in the notes for combining like terms, okay? And you should really follow these steps because it makes it a lot easier and you won't make as many mistakes, okay? So you'll see that those steps, the first one says to distribute if necessary. Well, you know how to use distributive property now. So the first thing you're going to look at is, do I need to use distributive property in this example? If the answer is yes, then you will do that first. If the answer is no, then you're going to move on to the next step. So I'm going to look at number 1 here, and I'm going to rewrite it off to the side here so I have more room to work. So I have 5m plus 3m plus 3 plus n minus m plus 6n plus 8. Okay, so what I want to do is draw shapes around the different like terms. Okay, so I'm going to start with the m's. So I'm going to go green. So there's 5m, and there's my plus 3m, and then I have a minus m, and notice I include the sign that comes before the term. So that's all my m's. So now what I'm going to do is combine all the m's together, okay? So 5m plus 3m is 8m, minus m is 7m. So I'm going to write that down, 7m. And I'm going to bring everything else straight down just like I would if I was doing order of operations. Okay, So I combine my m's. Now I'm going to combine my n's. Okay, so I have a plus n. And if there's no number in front of the variable, you're going to assume that's a 1. Then I have a plus 6n. So 1n plus 6n is 7n. So I'm going to keep my 7m. I'm going to keep my plus 3. That's going to be a plus 7n. I'm going to keep my plus 8. Okay, now I have to combine my constants. So I have my plus 3. I have my plus 8. So I'm going to keep my 7m. 3 plus 8 is 11. I'm going to keep my 7n plus 11. So there it is. 7m plus 7n plus 11 is the answer that we're looking for here. Now, it says that your coefficients, you're going to use your coefficients to combine like terms, which we did. These are our coefficients, right? So we added 5 plus 3, and we got our 8, and then we subtracted 1 to get 7. Okay? And then you are to write your answer in alphabetical order with the constant last. Well, m comes before n, right? And 11 is my constant that comes last. So that is how I solved number 1. Okay? So now I'm going to erase this, and we're going to do number 2. Okay, so number 2, I'm going to rewrite it off to the side. So I have 3a plus 5 minus a plus, whoopsies. Okay, let's try that again. So I have 3a plus 5 minus a plus 9a squared minus 4 plus 5a minus 5a squared. Okay, so the first thing I'm going to do is look at my a squareds because a squared outranks a. Okay, kind of think of it as when you play cards. Your ace outranks your king. So here our exponents outrank our variables that don't have an exponent shown. Okay, so I'm going to box those first. So I have a positive 9a squared here, and I have a negative 5a squared. Well, 9a squared minus 5a squared is going to be 4a squared. Okay, then I'm going to bring everything else straight down. So that's a positive 3a. So I'm going to write that as a positive 3a plus 5 minus a minus 4 plus 5a. Okay, now I'm going to box my a's. So I have a plus 3a, I have a minus a, I have a plus 5a. So 3a minus a is 2a, plus 5a is 7a. So I keep my 4a squared plus 7a. Okay, and then I'm going to bring down my plus 5 minus 4. Okay, now I need to combine my constants. So I have a plus 5 and a minus 4. I keep my 4a squared. I keep my plus 7a. 5 minus 4 is 1, so it's going to become a plus 1. So there's my answer. 4a squared plus 7a plus 1. Okay, so that's that one. Okay. Do you see how it's so easy if you go one step at a time and do your work one right underneath the other, bring everything straight down each time, boxing the like terms, and going step by step? Okay, now, number 3, we have 5 times the quantity 2b cubed plus 4 plus 6b cubed plus 10. So we do have to distribute here. Right, guys? So I'm going to go ahead and I'm going to rewrite this over here. So I have 5 times 2b cubed plus 4 plus 6b cubed plus 10. So I'm going to distribute my 5. So I'm going to take 5 times 2b cubed, and I will get 10b cubed. And then I need to take 5 times 4, and I will get plus 20. Then everything else comes straight down. Plus 6b cubed plus 10. Okay. So now I'm going to box my b cubes, right? Because that's my base, that's my exponent. So there's my base, there's my exponent. I'm going to keep my signs in front. So 10b cubed plus 6b cubed is 16b cubed, right? I'm going to bring down my plus 20. I'm going to bring down my plus 10. Now I need to combine those constants. So I'm going to box plus 20, box plus 10. Well, 16b cubed comes down. 20 plus 10 is 30. There's my answer. Okay, I hope it's getting a little bit easier. You're seeing how to combine these like terms. And then finally, let's do number 4. Okay, so number 4. We do have to distribute here, and it looks a little tricky, right? It's definitely not as tricky as it looks. So we have 3x, and then we have times 4y squared. Then we have plus 5x minus 3xy squared plus y. Now that looks super complicated, doesn't it, guys? But I promise you, it is not that hard, okay? So let's distribute. 3x times 4y squared. Well, all you're doing is taking 3 times 4 and getting 12. And then you got to keep your x, y squared. That's all it is. And then you're going to have plus 5x minus 3xy squared plus y. Okay, so now we need to look for same base, same exponent. Here's my base and exponent. Look, there I have those. They match, right? It's kind of like playing that matching game. I'm going to box those. So 12xy squared minus 3xy squared is 9xy squared. I'm going to bring down plus 5x plus y. So now I need to check the other terms. Are there any other terms that are like? Well, the answer to that is no. I can't combine 5x or y. They're not like. I can't add those together. Okay? They're not the same as xy squared. So that's it. That's my answer. 9xy squared plus 5x plus y. That's as far as we can take it. Okay, so I hope you learned in this video how to combine like terms, how to simplify it. What you need to remember is you're not going to end up with a final number answer a lot of the times. It's going to be an expression similar to this. I know your whole life you found an answer. It was a number. We're changing that now. We're taking things to another level. So you just have to get a little comfortable with that. It's going to take some practice, but you can do it. And it's actually kind of fun. It's like a puzzle you have to figure out. So if you have any questions, please email me. Come see me 8th period, and we'll get you figured out. Okay, thanks, guys.